Hello everyone and welcome to our Chapter 6, Applications and Dangers of Radioactivity for LH and SE sections. By the end of the session, you will be able to define the unit of measurement of radioactive rays, name the types of biologic and genetic effects of radioactive rays, give examples of the uses of radioactivity in medicine, outline the method of disposal of nuclear waste, name some detectors of radioactive radiation, and state methods of protection from radioactive rays. The radioactive rays are dangerous to the health and to the environment. If absorbed in high doses, these radiations provoke ionization that can destroy cells and lead to death. In weak doses, they produce burns, serious wounds, genetic mutations, and cancer. To be able to measure the dangers of radioactivity, let's start by defining the absorbed dose as the energy transferred to the unit mass of this body. This absorbed dose is expressed in gray in the SI unit, with 1 gray equals 1 joule per kilogram, and it is expressed in another unit too, rad, with 1 rad equals 10 to the minus 2 gray. Now, what about the biologic and genetic effects of radiation? It depends on the absorbed dose, of course, but on the nature of the radiation also. For example, for the same absorbed dose, alpha rays are 20 times more dangerous than beta rays. So let's define another quantity called the physiological equivalent of dose by the formula giving the physiological equivalent of dose equals absorbed dose times RBE, with RBE is the relative biologic efficiency. And the physiological equivalent of dose is expressed in sievert in the SI unit. And we can use another unit, the RAM, with 1 RAM equals 10 to the minus 2 sievert. And this is a table giving us some examples about the RBE of some particles. And here we can see that the RBE of the alpha particles is 20 times greater than the one of beta particles. For the same physiological equivalent of dose and for the same tissue or organ, the effects are identical whatever the received radiation is. And this is a table in which we can have an idea about the physiological equivalent of dose and the corresponding effects. We can see that if the physiological equivalent of dose is greater than 10, then this can lead to death. Now let's do an application exercise. A person of mass 77 kilograms receives 0.2 joule of energy from a radioactive source emitting alpha rays, given RBE equals 20. Question number 1. Calculate the dose absorbed by the person. We know that the absorbed dose is given by the energy received per unit mass, so we can divide 0.2 joule by 77 kilograms. And this is what we get in gray because joule per kilogram is equal to gray. Question number 2, calculate the physiological equivalent of this dose. And we remind you that this can be given by the formula absorbed dose times RBE. Then we replace the absorbed dose by 0.0026 and the RBE by 20, and we get 0.052 sievert. because when the absorbed dose is expressed in gray, then the physiological equivalent of dose is expressed in sievert. Question number 3. Referring to the previous table, deduce the consequences on the concerned person. So they ask us to refer to the table. And this is the table. What we got was 0.052 sievert. So if we take a look at this value, we can see that it can lead to a modification of the blood formula. So this must be the answer. Referring to the table, the person could have a modification of the blood formula because 0.052 sievert is approximately equal to 0.05 sievert. Now, what about radioactivity and medicine? Let's start by having an idea about the radiotherapy. Radiotherapy is a method that consists on destroying cancerous cells by irradiating the tumor by gamma rays. This treatment can have some side effects, among which are tiredness, loss of appetite, vomiting, and so on. This treatment must be achieved with a lot of precaution in order not to destroy the normal cells. Now let's have an idea about the scintigraphy. Scintigraphy is a method used to visualize several parts of the human body, like the lacrimal glands here and the skeleton here. Small amounts of a radio element, which preferably stick to the organ that should be examined or injected. Then a machine detects the gamma radiation emitted by the radio element in order to create the image. Let's pass to a third method called PET, positron emission tomography. Scientists implant a radioactive source of beta plus on molecules circulating in the brain. Then the patient is placed in a tube containing a set of detectors. When a positron emitted by the source interact with another molecule's electron, they annihilate and give birth to two gamma photons which leave in opposite directions. The analysis of these gamma radiations detected by a set of detectors placed around the patient's brain allows a meticulous study of brain activity. What about the nuclear waste? The nuclear waste can be divided into two categories. The first one corresponds to waste of short radioactive period. These wastes represent 90% of the nuclear waste, and they have a period lower than 30 years. They are shot in metallic barrels and concrete containers that are put in cement structures under a big insulated heap of clay. The second category corresponds to wastes of long radioactive period. These wastes are glazed and set down in cartridges of rust-proof steel, then buried underground at a depth of several hundreds of meters. Remark: nuclear wastes become relatively harmless after a duration of 10 radioactive periods. So, for example, for the waste of short radioactive period, they become harmless after almost 300 years. How do we detect radioactive rays? With a dosimeter, with a scintillation counter, or with a Geiger counter like the one in this figure. How do we protect ourselves against radioactive radiations? We have to move away from the radioactive source, stay in shelters having lead walls in the case of a leak, take specific medicines, protect the respiratory tract with special masks. And for some practice, here are 2 exercises taken from the official exams with the corresponding links. During the session, we learned to define the absorbed dose, to define the physiological equivalent of dose, to define radiotherapy, scintigraphy, and positron emission tomography, and to state some methods of protection from radioactive rays. Now I will leave you with the references and links. Thank you for watching and keep up the good work.